Hello, everyone. My name is Mackenzie. As was said, it's great to be here. I'm originally a Kiwi, so please don't hold that against me. But I've moved across the world to try and hide that. But so yesterday, if you were here, Ollie did a great talk on why we need to defend credentials and kind of some models and some maturity of how we can prevent, how we can keep our secrets secret. So today I'm going to do the opposite. I'm going to come at it from the attacker's point of view. I'm going to explain kind of how we can exploit secrets from that attacker's perspective and how we can do it using various different open and free tools that are there. So I don't really need to go into this because Ollie went through it yesterday, but what are secrets? So secrets are typically digital authentication credentials, API keys, credential peers, certificates, anything that authenticates us with different services and systems. So why do we have so many of these secrets today? There's been a fundamental shift in how we build software. We're no longer building these monolithic systems. Our software is more or less a collection of different building blocks. And in particular, we've really opened the door to third-party tools. So if I have an application, am I going to write my own credit card processing, or will I use Stripe or PayPal? Will I create my own authentication, or could I use Okta or Auth0? Should I create my own search, or should I use Algolia? There's lots of different areas that we can use, and we end up having this collection of different tools. But it doesn't stop there, because now we have cloud infrastructure, we need to host our code, our application, we need to test it. This all requires different tools that we use. Even once we build and ship our applications, the pesky marketing team, the sales teams are going to want integrations into different things. And of course, we have our own microservices that we've created that also leverage secrets. So this is a simplified version, but every single one of these is a potential entry point for me as an attacker. And once I get into them, I can generally find additional sensitive information, map out infrastructure, search for misconfigurations, and move laterally. So really, we've extended the attack surface quite far into this. So this is a website that you probably all know, GitHub. There's 83 million developers using GitHub, and last year, 2021, 50 million developers actually pushed code to an open source repository. So the volume on GitHub is absolutely huge. And it is one of the best places to be able to find and exploit credentials that you can imagine. So I want to do a very quick experiment to illustrate this. So here I have an AWS credential. This is probably the most obvious one that is useful for an attacker. This is actually a canary token, which means that it's just going to alert me whenever someone tries to use this key. So I have an open GitHub repository, and I'm just going to make a commit publicly. So this is the worst thing that you could ever do. Please don't do this. But we've just pushed our credentials publicly into GitHub. Now what we can do is we can watch in real time people trying to exploit them. So it takes a few minutes, so I'll continue on my talk, but I want to come back to that and analyze who, in the time that I've just been presenting, has tried to exploit those credentials. And while that's happening, I'll talk about exactly how those people are exploiting those. But first, some stats. So I work for a French company called GitGuardian, and every year we write a report called the State of Secret Sprawl. And in this, we scan every single public commit made to GitHub for the entire year. So last year, 2021, we scanned 1 billion commits. If you've committed anything to GitHub, we've scanned it and tried to analyze it for secrets. Last year, we found 6 million credentials that were published publicly on github.com. This is about a 2 times increase from the previous year. And on average, we see about 3 out of every 1,000 commits will contain a secret. Now, that happens in minutes on GitHub. So if you're a bad actor and you're wanting to exploit GitHub, you don't have to wait long to find something juicy. But we can validate these secrets. So one of the areas is secrets can be quite hard to distinguish between a high entry string, like a unique identifier, and an actual secret that gives access to. We have many techniques to do this, but one, we actually validate the secrets with the third-party providers. And this gives us really cool insights into what these give access to. So out of the 6 million credentials that we found, 21% were for data storage. That's over 1 million. And around about 1 million cloud provider. Valid cloud provider keys were leaked. So you don't need to be a genius to know what you could do with a cloud provider key. Of course, you can shut down services or disrupt it or exfiltrate data, but even if you're just using a personal account, I can mine crypto or I can use your machine and data to do nefarious activities. So lots of different things in here. Two of my favorite exploits, one of them is like the messaging systems. There's huge amounts of Slack credentials on there because people seem to like to create Slack bots, and often this is a personal project, so it's often kind of outside of work. But we find heaps of these, and it's one of my favorite exploits because if you can have a Slack token, then you can bypass some elements of trust and do internal phishing campaigns from the inside. So there's lots of different things that you can do from here. This one I just find really funny. So we found 500 commit messages where the commit message was the GitHub access token. So for reference, this is like sending an email with your password in the subject line. It's basically the same thing. So this just goes to show that we can find secrets in the most wild places. And we can also see some interesting insights. AWS is the most obvious kind of secret to leak. When I'm talking about this, I use that because everyone's familiar with it. But there is activity from AWS themselves to try and curve this. But we're increasing the number of providers all the time. So PlanetScale and Supabase didn't exist a year and a half ago. 2 years ago now. But now you can see, based on how many credentials we find for them, we can monitor the growth of those companies. But that makes it really hard if anyone's trying to prevent this problem from going into it. All right, so let's have a quick look back at our experiment and see if anyone has tried to exploit our credentials. So here we go. We've got them across multiple different countries, and here we have each time someone's tried to ping this for the moment. Now, so this one here is in India. Now, these aren't all individual people. What generally happens is you have bots that are scanning the GitHub API, which I'll talk about in a minute, and they're running calls to try and find out. So we can actually see the event name. So here it's got list clusters. So what would have happened is they first would have tried to find out if it's valid. Now they want to find out more about my account. So this actor is trying to do nefarious activities with a GitHub token I leaked literally 5 minutes ago. So how do we actually do this? I said that this is going to be a kind of a black hat talk, so I will share some information with you guys all, and I trust that you all do good with it and not bad things. But let's talk about, if we're attackers, how do we do this? There's so much information on GitHub. How do we actually find it? So the first one isn't very sophisticated, but it's the most obvious, so I kind of have to talk about it and just get it out the way. So there's GitHub dorking. This is basically using the GitHub search to try and find credentials. It's not very sophisticated, so here we can find a file called credentials, and I'm looking for AWS key in that file called credentials. And there's lots of different types of dorks that you can do. The reason why I don't recommend this for any potential bad guys out there is because, one, most of the secrets you're going to find are going to be buried in history. And this doesn't look at history, it only looks at top level. And the other thing is that there's just so much results that you're going to have to sift through. You'll probably be able to find something. A good one to do is to look for a commit message that says removed AWS key or removed API key, because then you just go back one layer and you're, oh, there's an API key there. But there's a better way to do it. And that's using the GitHub API itself. So if you go to this address, anyone can go to this address. We can do it right now. So you don't even need authentication for this. But this is the fire hose of information that is public GitHub. Right here is all the public activity that's happening in GitHub, including all the metadata. So I have the person's email address, I have their GitHub ID, I have what projects they're working on, and I can also find out information that they have on their bio in GitHub too. So there's huge amounts of volumes that come in this API. And using this API, we can find interesting things. So there's lots of different events that happen on here, but the two that you're most interested in are public event. This is when a private repository goes public. This is the best one. This is because people often forget that in Git, your history lives on forever. Yes, you can rewrite it, but that's a hassle, so most people wouldn't. So if someone's published an API key on a development branch, it got buried, it got removed, it got pulled into a pull request, and now it's public, they've probably forgotten about this. So the public event and also the push event is just when code is pushed to it. So we go back to the API, we can see the type of event that is happening somewhere. Here, so we have a push event up here. You probably can't see that. So it's easy to monitor. So now let's go through an actual workflow that an attacker might use to try and find a specific victim. One of the things about GitHub is that you're kind of protected by the sheer amount of volume that's coming in here. If I'm trying to attack a specific company, I'm protected by the fact that so many other people are leaking sensitive information that I'm going to be actually harder to find. So this is how kind of people get around that. The first one is you're monitoring the GitHub API, but you're not just scanning it all for credentials. You're looking for potential employees of an organization. So if I'm after Twilio, for example, I'm looking for someone with an @Twilio email domain in their commit metadata. Once I have that, I have their GitHub ID, and I know that that person works for Twilio. It doesn't matter if they then commit with their personal email address, I still can find that. So I can just look for that specific person, take their email address, pull down all their repositories, and monitor them in the future and scan their entire history. So when you have large organizations, you can build up really large maps and find specific things. Once you have that, once you've compiled your list of IDs, then you can scan the Git history using different shields. So GG Shield is Git Guardian's tool, but there's also other open source tools out there, Travelhog, Git Secrets. I'm biased, so I'll tell you that Git Guardian's the best, but you don't need to believe me if you don't want to. And the other workflow that we see is the spray and pray, which is just basically doing kind of specific searches on that information for specific keys. So AWS is the most common one. It has prefix characters. It's a set amount of length, so they're easy to find with some grep. And then those people go on to sell them on the dark web. So if you've ever been on any dodgy Telegram channels, there's lots of credentials being sold on there for specific companies, and this is really an entry point for every target. So you don't need to be the person that actually executes on this. You're just selling credentials. And Uber recently had a breach because credentials were sold on the dark web. And those kind of credentials can come from these types of places. All right, so now we've talked about GitHub. Let's talk about some other places where source code lives. So this is Docker Hub. You're probably all familiar as well. There's like 9 million Docker images hosted on Docker Hub publicly at the moment. So this is another huge collection of information. So we scanned huge amounts of Docker images to find out how many of them actually contained secrets. And the results that we have was nearly 5%. Nearly 5% of all Docker images hosted on Docker Hub have a plain text credential hidden in there. But most people don't kind of understand that you can decompile a Docker image and pull out kind of any extractable information in there. People kind of tend to think of it as a black box. So again, huge amounts of sensitive information that's sitting out there in the public for anyone to use. So how do we attack Docker? What's the workflows that we can use here? Well, the secrets in Docker are slightly different to the secrets that we might find in Git repositories. So of course, if you have plain text credentials in your code that gets pulled into Docker, they're going to live in your Docker image as well. But we also find other ways where secrets end in here. And it's important to know that Docker is just a series of code that's been compiled in layers. So this here is what a Docker image looks like on the inside. On the left here, what you'll see is moving is these are the different layers. So a Docker image is built up on layers determined by your Docker file. And you can see what's in green is what's been added. So here we have a whole bunch of code that's been added in this layer. Why this is important is because we can go back through the layers of this build. So we'll see people doing interesting things. For instance, here is an example of something we might find where you have a file that contains a credential. You've added this credential in your build process, you've used it, and then you've gone to remove it, and now you think that your final Docker image is going to be free from that credential. It won't be. It will be just hidden in some layers. But like Git history, then you can just go back into these layers and uncover these plain text credentials. So lots and lots of sensitive information, and this can be much worse than Git as well, because here we're often going to be able to have credentials that's going to allow us to publish packages. So we can turn a package malicious and ship it without anyone suspecting. So the kind of last area that I want to talk about is private repositories. So one thing you need to know about private source code and private code repositories is that they're really, really bad at staying private. So just to take a look inside, if you take a look at kind of the average customer that GitGuardian has, we've got 400 developers with around about 4 AppSec engineers. When we do a historical scan, we'll generally find about 13,000 secrets or about 1,000 unique secrets. So this is kind of like a middle range organization. That's 1,000 different unique secrets that each have to occur around about 13 times throughout different areas. So this is a huge challenge that we face because source code isn't meant to be protected like a secret asset. Source code is meant to be distributed. And just because our source code leaks shouldn't mean that all our security protocols fall apart instantly. But that's kind of what happens because deep in the history and in other areas, we have all this sensitive information. But we have no control over who has access to it, or we have very limited control. We have no audit logs of who's actually downloaded that. And once code sprawls into different places, we have no idea where it ends up. So here, and there's also other ways to abuse source code. So if you get access to a developer account, you can abuse the internal API, so just like we were kind of abusing GitHub's API before. So if you're using GitLab or GitHub Enterprise or Bitbucket Server, then these will come with internal APIs that you can use. There's a tool called SCMKit, which will automatically go through various steps to try and elevate privileges, create duplicates of or cloned admin accounts, use impersonation tokens, all with the idea to try and elevate your privileges in a private repository and get you the most amount of access. So even if you tell me, yes, Mackenzie, but our developers are all segmented, they have different access to different repositories, no one has overarching access apart from the admins, well, there's internal tools that you can use that will actually try and bump you up to that admin access and get you access to things that you shouldn't have as well. So we can use this, abuse our internal APIs, elevate our privileges. We can abuse pipelines. We can inject malicious packages. We can dump environments. We can do all of these different things if we can get access to that private code repositories. And developer accounts are being sold everywhere on the dark web and in dodgy Telegram channels because they're not highly protected, but attackers really, really like them to do internal kind of campaigns against them. So once we have access to it, of course, we can scan the entire repository with the same tools. But a funny story, we had some people that were telling us that their code is very clean, it's very segmented, developers don't have access to any production credentials, so they wouldn't be in the source code. And we had a look at it, and we were running through their CI/CD pipelines, and we saw that they were using dev for development credentials. And we thought, I wonder what happened if we changed dev to prod and then dumped out the environment variables. And that was all it took to get access to the production credentials from a developer account. So there's lots of different ways that this can be exploited. Now, talking about private open source now. So here we have what I like to call involuntarily open-sourced repositories. So Cyber News recently did some wide-scale scanning on different ports and domains to try and find .git directories that were exposed. So they found about 2 million .git directories that were publicly accessible. So a .git directory or .git folder contains all the metadata. It's not a repository, but it has all the history in it. And you can reconstruct a repository from this folder. So roughly 2% of all the domains that they scanned contained at least one .git directory that was exposed publicly. So this is just a huge amount of private source code that's accidentally been leaked publicly, or at least remote accessible. And this is really scary because remember I showed you the stats of that you're going to have 1,000 credentials occurring 13 times in a private repository. Well, this is where they ultimately could end up exposed to the public. So massive problems that we face here as well. So how would we discover these exposed .git directories? Lots of different ways to do it. So if you have a victim domain, try and narrow that down to as little as possible, but then you can find subdomains and other addresses with chaos or subfinder, and basically map out the infrastructure and try and find as many open addresses and open ports as you can. Find the assets using a mass or DIR search. These are all open source tools. And then there's even tools that will help us reconstruct those .git directories and try and exploit them. So GitHat or GitHacker all do this as well. These are all open source tools. And then, of course, the last step, we scan them all for credentials. So this isn't very sophisticated. Why I'm kind of showing you this workflow is just to show that this whole process of finding credentials in every step contains open source tools that really anyone can use to be able to automate this process. So it's not a highly sophisticated attack, and it lowers the bar to entry of who can really gain access into your organization. So I want to talk about some actual attacks that have happened using this. It's all very good talking about theoretical things, but let's see what actually has happened out there in the dark web spaces. So the first one I want to talk about is Codecov. So you may have heard about this attack. It happened last year. So Codecov is a code coverage tool that sits in your CI/CD pipeline. Basically what it does is it tests how much of your code is being tested. So it does a very specific job. Codecov is a really cool product. I use it myself, but even cool products can make mistakes and kind of cause a harm to a lot of people. So at the time of the breach, they had 23,000 customers. And so let's talk about exactly what happened. So in January, they launched their official Docker image, they updated it, they put it in Docker Hub. Anyone could have pulled this down. This was what was the official image to use for Codecov in their Docker image. So the attackers pulled down this Docker image, and then they scanned it and found a hard plain text credential in here. This plain text credential gave them access to a data storage that contained a bash uploader script that was being pulled by the application. They were then able to inject malicious code into this bash uploader script, which would run every single time one of those 23,000 customers used Codecov. So lots of big companies were using Codecov at that time: Rapid7, Twilio, Monday.com, HashiCorp. And what happened was that one line of code said, every time someone runs this testing tool, I want you to take all the environment variables and I want you to send it to me remotely. So hopefully, in a testing environment, you're using test credentials and you're not using production credentials, but we all know that that's not always the case. But even some credentials, like you will need your GitHub access token, which can't be test credentials. And this was specifically what the attacker was after. They were after access to private repositories of Codecov's customers. And I want to talk about one here. Oh, this is the line of code, if you're interested. This is the bash uploader script. It's really nothing special. It's thousands of lines of code. It's kind of ugly. You wouldn't want to be the engineer responsible for it. And then buried in here on line 525, you had this one nefarious kind of line. Now, I'm going to pick on one of the companies that were affected by this, and that's HashiCorp. In yesterday's talk, Ollie mentioned the HashiCorp Vault. Fantastic product, and it is. It's probably the best product for storing and managing your secrets. HashiCorp invented the term secret sprawl, which is when secrets kind of get out of control, and these huge amounts of information about how to keep your secrets out of source control that HashiCorp provided. The attackers got access to HashiCorp's private repository, and there were secrets inside of it. So if the company that invented secret sprawl, that has the best product for managing secrets, has secrets exposed in plain text in their private repositories, then there's no hope for anyone else. And so that's basically where we're at. So there was private keys that were exposed, that were valid in HashiCorp's private repositories, which the attackers got access to. So let's talk about using public GitHub now to launch an attack. So I'll talk about SolarWinds. I'll preface this by saying that the SolarWinds attack was really sophisticated. It contained lots of different elements, and I'm going to talk about one of those elements that I think was a link in that chain, but this isn't kind of the only thing that happened. But we know that in September 2009, threat actors gained access to an FTP server that they were using to update code. Also in September 2009, a SolarWinds employee published on their personal GitHub account the credentials to a SolarWinds FTP update server. The password was SolarWinds123, if you're curious. And this was actually found by a security researcher who notified SolarWinds, and those credentials were revoked. But the attackers were already able to gain access to the FTP server. So they were probably able to persist their access, use different techniques, but this was basically one of the first initial points that then set off the chain that followed, that was the SolarWinds attack, which again, very sophisticated. It wasn't just the fact that this password was leaked that this happened, but definitely a part of it. And so here we have threat actors that were clearly targeting SolarWinds from everything that we know, that were looking at SolarWinds employees to try and see if anyone leaked any of the information, and they did. Now, the last one I want to talk about is private code repositories. So we talked a little bit about finding the exposed.git directories and other areas, but what are some things that have happened about private code repositories? Well, this year has been the year of source code leaks. There's lots of source code that has been leaked from Microsoft, Nvidia, Twitch was last year, and a lot of these are great companies with great security posture. So, you're curious, how is all of this source code being leaked? So we can take a look at some of those to get an idea. So first, let's look at Twitch. Twitch's source code was leaked because of a misconfiguration in their Git server, which basically allowed remote access. So a human mistake, and then 6,000 repositories were then released onto the world via a torrent. Now, the media all took this up, and the main points that they made were that this exposed the streamer's income. And I learned that Twitch streamers earned a lot of money. But there was much more interesting things that happened in here. We scanned this for secrets, and we found 6,600 different secrets that were inside Twitch's source code. So huge amounts. This isn't that alarming, though, because the size of Twitch, this is roughly in line with what you would expect, right? This isn't anything special. In that, we found 194 AWS keys, 69 Twilio keys, 68 Google keys, 14 GitHub OAuth tokens, and even 4 Stripe keys. So lots and lots of different information. Now, in this case, the malicious actor wasn't all that malicious, because they leaked it publicly, which is probably the best thing that they could have done. Because there was so much sensitive information in here, Twitch knew they had a problem and were able to rotate and revoke most of those credentials before anyone could use them, rendering them useless. But they were still there. And if that threat actor wanted to be a little bit more malicious, then there's lots of different things that they could have done. And even if they didn't want to carry out the attack, you can easily sell these credentials for people that do. Now, the other one is, let's look at Nvidia. So Nvidia, another great company with great security posture. We know that when their source code was leaked, it contained cert keys that were used to sign Windows malware. The keys were actually expired, but just of how the elements of trust work, they were still accepted by lots of systems. So how did this all happen? Well, we know that this was from the Lapsus group, and later we found out that Lapsus was a group of teenagers. So you wonder, how does a group of teenagers get access to so many of these different companies' private source code? And the simple truth is they just buy their way into it. This is the Lapsus Telegram channel, and on here you can see that they're recruiting insiders at the following companies. And basically, they will pay you to give them access to your VPN, to your private Git repositories. So if you're an intern, or you've just been fired, or you're struggling, then how tempting would a couple of grand be just to give someone access to a Git repository, and you don't even think that that's much of a problem? But from there, we know that they were able to gain and ransom lots of information and exploit Nvidia. And they also did this with Microsoft and Samsung as well. So it's, when you look at who should have access to secrets in your organization, there should really be no one that has access to all secrets. It should be segmented. They should be strictly controlled. We need access logs of who has access to these. But if you think about your Git repositories, we have none of that. So if these secrets are in your Git repositories, then everyone that has access to those Git repositories has access to those secrets. And even if you have segmented repositories for different areas, which is kind of annoying, especially if you work in security and you have to float around different and always request access. But there's tools that can kind of elevate your privileges for this, that will seek out misconfigurations and seek out additional credentials. And so the last one I want to talk about just quickly is the Uber breach, because this one's kind of similar, and this one presents, in my opinion, just the worst case scenario imaginable. So if we start at the top, a credential was sold on the dark web to a bad actor. Again, we believe this was part of the Lapsus group. And props to GitHub, they had multi-factor authentication on it. So this was for a VPN to give them access to the server. But using some phishing campaigns and basically kind of spamming, calling up the security team saying, hey, we need access immediately, can you please accept the MFA? The user accepted the MFA, and the threat actors got access to Uber's internal VPN. Uber's had lots of trouble in the past about leaked secrets. Uber employees have leaked secrets on GitHub, which led to data exposure. But in this case, they just got access to the internal networks via VPN. But then they started scanning the infrastructure, and they actually found some PowerShell scripts that were version controlled also. And inside these PowerShell scripts were hard-coded credentials. So these specific scripts were basically used there when someone joins the company and you need to give access to different areas. They'd run through these PowerShell scripts, and it would give access to different things. Why that's important is because, to enable to do that, there was the admin credentials to the PAM system hard-coded in the PowerShell script. So a PAM system is like a secrets manager and a passwords manager combined into one. It controls access to everything in the company. So using this, they basically had admin access to every single system that Uber was using that ran on that PAM system. It's called Psychotic. So they got access to their AWS, their GCP, their Google Drive, their Slack, their Sentinel-1, which is threat detection, so they could have even turned off threat detection. Again, lucky for Uber, the actors weren't all that malicious and were mostly after clout, because immediately once they got access to these things, they started spamming the internal Slack channels and making lots of noise in social media about having kind of hacked Uber. They could have done much more nefarious things. Considering they had access to even the threat detection, they could have turned off detection for basically to persist their attack, had they been slightly more malicious. So why does this happen? We should all know that putting secrets in code is bad, right? So why do we always put secrets in code? There's lots of different reasons for it. And the one reason that you could just sum this all up with is basically human error. But GitHub in particular is unique that we have one we often have one account for our personal and professional use. So we may have them configured differently locally, but it uses the same credentials. So we can accidentally push code intended to our organization's private Git repository to a personal one. We have secrets buried in our Git history that we forget about or don't know about, because the nature that it is, if you remove a credential, goes to code review, you're probably not going to find that credential. You have auto-generated files like debug logs that often have dumps of the environment variables that git add all collects them, and if you don't have a .gitignore file configured, it will just be accepted into the repository. And then, just kind of like the final point down there, I just see lots of people managing secrets in Git. We probably heard about the meltdown of FTX, the crypto exchange. Their secrets manager was a group email. They were sharing credentials on a group email. So people are doing this in kind of really, really weird ways. So how do we harden this? Well, of course, we need to have secrets managers. So Ollie's talk, this whole slide could just be listened to Ollie's talk yesterday. But, use vaults where possible and use key management solutions. The best vault isn't always the best vault for you, because they can be very complicated, and you really need your engineers, your developers to use them. So it has to be accessible. Never store secrets inside Git repositories. Use short-lived credentials. Don't make a credential lived forever. This should just be standard and have auto-rotation policies in place. Restrict the API to a minimal scope. Just because I have an AWS key or an API key doesn't mean that it should automatically trust me. We can limit who's trusted in this environment. We will need to add automated secrets detection. So this is kind of finding these secrets. We can use lots of different tools to be able to do this. As organizations, we need to implement that as a strategy, because most of these companies that I talked about wouldn't have been aware that there were secrets in their internal systems, because they're kind of hard to pull out, especially at scale. So we need to add in that automated secrets detection, and we can also use canary tokens, like what I did at the start, to monitor bad guys. We can litter them in our internal infrastructure to be alerts if someone that shouldn't be in there is using one of them. So that's it from me. I have 2 QR codes here that will give me a backdoor into your phone. Just kidding. But these will take you to some reports that we have. So we have GitGuardian has a secrets maturity model, or if you're interested in some of the reporting that we have, or the research that I showed, the State of Secret Sprawl report is on your right. So thank you all so much.
Well, if anyone has a question for Mackenzie, oh, yep, there's one at the back. Got a few minutes for a couple questions.
Sorry, just a quick question from earlier in terms of searching for credentials on GitHub when you're targeting a specific company or victim. You mentioned one of the primary ways to narrow down your search was to look for accounts that had the domain, or look for specific developer accounts. But I feel that might miss quite a large attack vector of people's personal accounts leaking source code. So wouldn't it be better to combine that with a method of also perhaps checking for a license involving the company name or the company name within the code somewhere, rather than just looking at those accounts?
Yeah, absolutely. And with the email address and the metadata is configured locally. So you have one GitHub account for both your personal and professional use. So if you're using your company's account, then I know that you work there, and I can track your personal email address now too. But definitely looking for keywords in there. The difficulty is that when it comes to monitoring, when it comes to dealing with GitHub, you're dealing with such a large scale that you need to kind of take a step back. And if you're looking for keywords, then you have to actually start scanning the code and go deeper than just the metadata. So at scale, and especially when you're talking about larger companies, I always take the easy road and just find what I can in the metadata and start there. And then once I have interesting results, maybe going a little bit deeper. But definitely you're right, and I think it all depends on how much time and computational power you're willing to put into this, especially at kind of that largest scale. So yeah, I think it just depends on really what your investment you want to be.
Cool, thank you.
Well, thank you so much, Mackenzie. We hope you haven't inspired any malicious plots in our attendees today, but we really appreciate having you here at Hack Sydney. Thank you so much. Let's give him another round of applause.